In the final video on properties of logarithms, we will be considering two and really three. I mean, they are separate contexts, but the formulas are essentially the same. Applications of logarithms. And now, when I say applications, you immediately think word problems. And so, yes, they are going to be word problems, but they're not going to be too bad. So just relax. They'll be fine. Okay, so the first example is about pH. Okay, and so in chemistry, you may remember, maybe you've talked about it, maybe you haven't, but pH, when it's reported, it's a number 0 through 14, and then if we get a number that is under 7 for that solution, it's said to be acidic, and then if it's over 7, it is said to be basic. And then note that to calculate pH, we have to do the negative log of H3O plus, and so that is the hydronium ion concentration, and that's going to be expressed in units of moles per liter. Okay, and then this is just a little image that is taken from a textbook showing pH. Okay, so the other example is really R is equal to log of I over I naught, and D is equal to D is equal to 10 times log of I over I naught. And I is really going to be the threshold that we need to obtain. But in any case, R is called the Richter scale, so that's measuring earthquakes, the intensity of an earthquake event. And the decibel scale is, or the D is for decibels for sound, and so D or I naught and the decibel scale context is kind of like the minimum threshold of hearing that you need. Okay, and then they do have a calculation for that. Okay, so just a little bit about the three contexts. Okay, so we have two examples here, and so we're going to tackle the first one, and then I'm just going to show you the solution to the second one. Okay, so first example: detergent added neutral water. Its pH is water has a pH of 7, results in a hydronium ion concentration that is weaker than that of water. What is the pH of the detergent and the water solution? And so the first thing I'm really interested in is well, pH of detergent and water solution. Well, it would be nice to know, it says the hydronium ion concentration is that weaker than that of water. I really want to know what is the hydronium ion concentration for water. I want to know what that is. So then that's where the pH is equal to negative log base 10 of the hydronium ion concentration formula comes in handy. So then if I know the pH for water is 7, I can say, okay, well, this is going to be negative log of H3O plus, and so I change the signs over here, so then we have that. And now this is where our good old friend the tattoo is going to come into play. So we can remember that this is base 10, so we could say, converting this into exponential form, this is going to be 10 to the minus 7 is equal to H3O, or the hydronium ion concentration for water. Okay, so I have found that. Now, that means then that the H3O plus for the solution is going to be the 10 to the minus 7, so that's water. But then it says it's going to be 5.62, let me just erase that a little bit, 5.62 times 10 to the minus 4 times weaker. Okay, and then so really what this results in for the hydronium ion concentration for the solution is going to be 5.62 times 10 to the minus 11. Okay, and so then now what I'm really interested in is the pH for the solution. Okay, and to get that, all I'm going to do is use the formula pH is equal to negative log. So pH is equal to negative log of the hydronium ion concentration, which I said was 5.62 times 10 to the minus 11. Okay, and now this I have to use a calculator for, so I'm going to take out my calculator and I'm going to type into it negative log 5.62 times 10, and that's the E button if you haven't discovered that. Minus 11. Okay, and when I do it, I get the pH is approximately 10.3-ish. Okay, and so this would be basic, which makes, I think makes sense based on the detergent. Okay, as detergents are generally more basic than acidic. So this makes sense in the context, and so I would just do a sentence to conclude this. I'm not going to take the time in the video to do that, but remember, contextual examples require sentence conclusions. Okay. Now, for the next one, the cat's purr problem. For that one, we're talking about hearing. We're talking about sound. We're going to be talking about the decibel scale. So just as a reminder, the equation there was d is equal to 10 log of I over IO, and IO was the threshold of hearing. Okay, so now here, this one, I think, this one might take a little bit of time to wrap your brain around, but it's saying that for a purr, that's going to be 316 times the threshold of hearing, which the threshold of hearing is defined as IO. So then there really isn't that much to do. You put this in, so 10 log 316 IO over IO, and voila, those cancel out, so you end up with 10 log 316, and then again, going to your calculator, 10 times log, 10 times log 316, helps to hit the right buttons, and I get approximately 25-ish decibels. Okay, and then I would just conclude in a sentence. Okay, so these problems, they don't require a lot of work. Generally, it's just you might, particularly with the pH problem, you might need to do a little bit of thinking around it. And so make sure to ask if you have questions, and consult peers as needed as well. Okay, that's going to wrap up this video.